Arjun. In today's session, we'll see the problems on modal analysis using Ansys. The given problem is conduct modal analysis for a fixed beam and obtain mode shapes and first find natural frequencies for a beam loaded as shown in figure with Young's modulus 200 GPa, Poisson's ratio 0.3 and density 7800 kg per meter cube, and cross section of the beam is 10 into 10. Length of the beam is 1000 mm. Okay, now we'll see how to solve the problem using Ansys, and I'm using 14.0. Now go to preferences, select structural analysis, click on OK, and then I'll go to prepressor, element type, add, I'll select beam element for this, click on OK, close it. Then go to material properties, material models, structural, linear, elastic, isotropic. The Young's modulus is 200 E power 3, Poisson's ratio is 0.3. I'll enter those values, click on OK. Now one more difference between this and normal beams is we need to give density for this. So density will be 7800. So if we convert that into Newton per mm, so e power minus 9, click on OK. Now the density and material properties are entered. Go to sections, beam, select common section. Now specify the type of cross section given, so square cross section with the dimensions 10 by 10 mm. So specify the dimensions. Now we can go to modeling, create. So I'll create the model using key points method, key points in active coordinate system. So key point number 1, potential coordinate is 0, 0, apply. So key point 1 will be created. So now go to key point 2. So total span is 1000 mm. So key point 2 will be at a distance of 1000. So now both the key points are created. Once you create a key point, we need to create lines. So I will go to lines, straight line, select key point 1 and key point 2, click on OK. Now the element has been line has been created. So once you create the line, we need to mesh it. So I will go to meshing, mesh tool. So first set the lines, click on line, select the line, apply. So if you want, you can give the element edge length or you can leave it as it is. So I will divide this into 100 subdivisions. Okay, then go to mesh tool, click on mesh, select pick all, so that now the line will be totally meshed. Now we need to apply constraints for this. In order to apply constraints, so now the parameters will change. Now we need to go to solutions in order to apply the constraints and other loading parameters. Now I will go to solutions. Here go to solutions. We have something called as analysis type. Now select analysis type. So keep observing this. So if I select new analysis, so the types of analysis will come here. So static, modal, harmonic. So now we are doing modal analysis. I'll select modal, click on OK. So now you can observe here these commands have been changed. Now there is something called as analysis options. Just click on analysis options. So let this be default and number of modes to extract. So you can give 5. In the problem they have asked with 5. So you can take 10. Any number of modes that you need. So 10 modes to expand. So each mode will be repeated twice. So I will take 10. So let this be starting frequency is 0 and ending frequency is 0 because there is no load acting. So let the both starting frequency and ending frequency will be 0. Okay, then go to define loads, apply, structural, displacement, on key points. So on key points I'll select key point 1 and key point 2, click on OK. So all degrees of freedom, I'll constrain this in all degrees of freedom. Key point 1 and key point 2 are fixed. So you need not to apply any force because there is no load acting. So directly you can solve the problem. Go to solve, current LS. So now the problem is solved. You can close it. Then in order to view the solution, go to general post processor. There's something called as read results. You can go to read results, select by pick. You can see the frequencies which are obtained. First frequency is 1.6453, second frequency is 4.5334. This is third one, fourth frequency, fifth frequency. We have, since as I told, each frequency will be repeated twice, it will come back to its initial position, and that is the reason why I have selected 10 modes to extract. So close this. If you want to see the mode shapes, go to plot results, deformed shape, select deform plus undeform, OK. Then go to read results, click on next set. Then again go back to plot results, deform plus undeform. So you can see this is initial mode, then read results, next set, plot results, deform shape and deform. So you can see the mode being generated. Similarly, by repeating the same procedure, next set, plot results, deform shape, deform plus undeform. So again now it will come back to its normal position. If you want, you can change the views here. See there, you can see. Similarly, read results, next set. Again go to plot results, deform plus undeform. See, now it is being repeated twice. Again read results, next set. Then go to plot results, deform shape, deform plus undeform. See, now we can see mode 3, third mode, read results, next set, plot results, deform shape plus undeform. So this is another side, next set, plot results, deform shape. So likewise you can obtain any number of modes that you require. Okay, and for the same way you can do fixed end and free end, fixed free beam also in the same manner. The only variable is you need not to fix another end, that will be fixed free or pinned free condition. For analytical solutions, please check the link given in the problem. Thank you.